All right, welcome back. In this next example, we're going to be comparing numbers in scientific notation. So to do that, first compare the powers of 10. All right, the number with the greater power of 10 is greater. So let's look at these two examples in scientific notation. So what this is saying, first, you compare the powers of 10. So here, 10 here. And the powers of 10 that we're really comparing is this 4 and this 8. Which number is greater? Well, 8 is greater, so that means that this number is bigger. Okay, so this is the bigger number, or the greater number. All right, so we don't even look at this. Okay, we just first look at the powers of 10, and whichever has the greater exponent, that is the bigger number. Okay, if the powers of 10 are the same, compare the values between 1 and 10. So here we have these two numbers. If you look here, 10 to the 4th and 10 to the 4th, those are the same. Okay, so then what we are going to compare are these numbers right here. Compare the values between 1 and 10. And when we do that, 9.5237 is bigger than 3.5935, so we know that this number right here is the bigger number. All right, let's look at a few examples to see how we're going to apply this. Okay, so we're going to be looking at some life science application problems. So this says the major components of human blood are red blood cells, white blood cells, platelets, and plasma. A typical red blood cell has a diameter of approximately 5 times 10 to the negative 6 meter. A typical platelet has a diameter approximately 2.789 times 10 to the negative 6 meter. Which has the greater diameter, a red blood cell or a platelet? So we have two things, right? We have our red blood cell, which is this here, and we have our platelet, which the diameter is right here. So as I'm looking at these two numbers, right, it looks like if I was to write this, we have the same, we're always going to look at that power of 10 first, right? So it looks as if the power of 10 is the same, right? So since it is the same, we look at these numbers here. And whichever number is bigger, that's the one that we go with. And 5 is bigger than 2.789, so this is the bigger number. Okay, which is, what is this? This is the red blood cells. Okay, so which has a greater diameter, a red blood cell or a platelet? A red blood cell does. So that would be the answer. Okay, let's, actually, I want you to go ahead and try B, okay, on your own. Here we go. So I want you to try B. Do not try C. We'll do C together, but I want you to try B on your own. So here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work out the problem. When you get done, press play and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. It says a certain cell has a diameter of approximately 4.11 times 10 to the negative 5th meters. A second cell has a diameter of 1.5 times 10 to the negative 5th meters. Which cell has a greater diameter? So when we look at these two numbers, we have 4.11 times 10 to the negative 5th and 1.5 times 10 to the negative 5th. So we want to look at that powers of 10 first, right? And what do we see? We see that they are the same. So if they are the same, then we just look at these numbers. And we know that whichever number is bigger, 4.11 or 1.5, this is a bigger number. So we know that this cell has a bigger diameter. Okay, so it says which cell has a greater diameter. We're just going to say the cell with a diameter of 4.11 times 10 to the negative fifth. And that's our answer. If you got that one right, great job. Okay, let's move on to part C. Okay, we're going to do this one together. Part C says, okay, the E. coli bacterium is 5 times 10 to the negative 7 meters wide. A hair is about 1.7 times 10 to negative 5 meters wide. Which is wider, the bacterium or the hair? So we have bacteria, which is 5 times 10 to the negative 7, and we have a hair, which is 1.7 times 10 to the negative 5. Okay, so it always says look at the powers of 10 first. So if we look at these powers of 10, they are not the same. So this is great. We can just tell which one's bigger just by looking at this. Now this one's a little tricky because unlike our example, in the two examples, right, where we were looking at here, the powers of 10, and this one was bigger, 4 and 8. These were positive numbers, right? And remember what you're doing. You're multiplying by 10 4 times. And here you're multiplying by 10 8 times, right? So this 8, this is bigger. So we know that this whole number is bigger because you're going to multiply 10 by itself 10 times, 10 times, 10 times, 10, you know what I mean? So, but here, what are we doing? This negative, which means we're dividing by 10. So we're going to take this number and divide it by 10 7 times. So 5, we're going to divide it by 10 7 times. So that means, you know what I mean, it's going to be divided by 10 and then divided by 10 and then divided by 10 and then divided by 10, right? 7 times. And this one is going to, 1.7 is going to be divided by 10 5 times. So, that means the more times that you divide it by 10, the smaller the number is going to be. And so we are dividing this number by a less amount of 10. So that means that this number is actually going to be bigger. And whenever you're dealing with negative numbers, you want to think about, okay, so what number is closest to 0, right? And if you look at that number line, here's 0, 1, 2, 3, 4, 5, 6, 7. So this is negative 7, 1, 2, 3, 4, 5. Negative 5 is here, and negative 5 is closer to 0. That means negative 5 is bigger than negative 7. So that means that this is bigger, which was 1.7 times 10 to the negative 5. That's talking about a hair. So which is wider, the bacterium or the hair? And we would say the hair is wider. All right, now that is it. I will see you in the next lesson. Great job with this lesson.